quadratic, what does it have in it?
Square.
It has a square. We have an x squared in it. So number of terms, you could have like an x squared, an x, and a constant. We don't necessarily have to have all of them, but if it's quadratic, it has that x squared. What's the graph of a quadratic always look like? Parabola. Okay, what we are going to start doing is solving equations, solving quadratic equations. And to do that, you are going to use what's called the zero factor property. So it says if you have two numbers multiplied that equal 0, one of those things has to be 0, or both. Now this only works if it's equal to 0. If you multiply two numbers and get 2, does it mean one of the numbers had to be 2 to begin with? No, only 0. So with our quadratics, we will always set them equal to 0 and then factor so that we are able to solve. So if I asked you to solve these equations, we know that our goal, if we're going to use the zero product property, is to set this equal to 0 and factor it. We've done factoring before. The only piece we didn't do is go ahead and solve them. We didn't have equations at the time. So if I want to set this equal to 0, we know that when we factor, we prefer the x squared to be positive, so I'm just going to bring everything over there. So I'm going to add my x and subtract my 12. Now we need to factor. Because it's a 1x squared, we can do the shortcut. So x squared breaks into x. What two numbers multiply to negative 12 and add to positive 1? Negative 3, positive 4. So then we set each of those equal to 0. So we get x equals positive 3. And x equals negative 4. We should always get 2 answers on these. Well, usually we'll get 2 answers.
How'd you get negative 3 and 4?
Multiply to a negative 12 and add to a positive 1. Now, if you think about a parabola, we're basically saying how many times does this graph equal 0? How many times does it hit the x-axis? So at most, that would be 2 times. Now, would it be possible to have only one answer where it hits 0? Yeah, if you just think about like this one, that only hits once. Is it possible to have no answers? Yeah, you could have a parabola that never hit the x-axis. So we'll get 0, 1, or 2 answers on these, no more than that. B. What could I do for that one? It's already equal to 0, so then we need to factor. Can we do box method? No. What can we do? If it was x squared minus 9, we would do that. How could we factor it?
Take out an x.
Yeah, we could just do greatest common factor. First step to factoring is pull out any greatest common factors, which in this case, they both have an x. So zero factor property says if you have two things multiplied that equal 0, one of them has to be 0. So either x equals 0 or x minus 9 equals 0. So my answer is we get 0 or none. And you can always check these by plugging them back into the originals. So far, so good? Sometimes we get the same answer more than once. That is called a multiplicity. So repeated solutions are called multiplicities. You might want to jot that term down if you don't remember that. That's the next problem. X squared minus 6x plus 9. It's already equal to 0. There's no greatest common factor. Because it's a 1x squared, we can do the shortcut box method. squared breaks into x, what two numbers multiply to positive 9 and add to negative 6?
3 and 3.
Negative 3 and negative 3. So if we set each of these equal to 0, you get x equals 3 and x equals 3. So a lot of times we will write that as 3 and then we put a lowercase m and a 2. 3 multiplicity 2. That means 3 is the answer I got, but it happened twice. That's a repeated answer.
Do we have to write it like that?
We will need to eventually. When we start getting into all the polynomials and the graphs, that multiplicity changes the graph. So we might as well get in the habit now. D, what would I need to do? And then what?
You can do box method.
Box method. We can't do the shortcut because it's not a 1x squared, so we need the full box this time. So we need two numbers that multiply to a positive 36 and add to a negative 12. Negative 6, negative 6. So then if we factor, 4x squared and negative 6x would be the 2x. Negative 6x and 9 would be a negative 3. 4x squared and negative 6x is 2x. Negative 6x and 9 is negative 3. What do you notice about those?
Repeat.
They're repeated. So when we set it equal to 0, I really only need to solve one of them. So 2x equals 3, which means x equals 3 halves. But what's the multiplicity there?
X equals 3 halves and 2.
It showed up twice because I had two parentheses that were like that. All right. Questions about solving these things by factoring?
So you can only do box method when the x squared is 1?
The shortcut box method,
Yeah.
yeah. And if it's not a 1, then you have to do the full box.
Okay.
Okay, one other strategy that I want to talk about today is what's called the square root method. So let's say I gave you this problem. X squared equals 5. Okay, we could subtract that 5 over and then try to factor. But our goal is to solve for x, right? And I have that x squared on the side by itself. There are no other x's in the problem. What is the opposite of a square? Square root. If you need to add a square root, what else do you have to put with it? So I get x equals a positive or negative square root of 5. Can we break down the square root of 5? Nope. So that's our answer. So sometimes it's really easy just to go ahead and square root to solve. So on f, we have two options. I can multiply all this out and then do box method to factor. Or could you solve for x the way it's written right now? What would we need to do to get x by itself?
Square root. Well, not square root. Times x minus 2 by itself.
Okay, we need that x minus 2 squared by itself. So let's start out dividing by the 3. And you get that 3 away. (48) divided by 3 is 16. Then, to get rid of a square, we square root plus and minus. So you have x minus 2 equals plus or minus, what is the square root of 16? 4. So this is really two separate equations. X minus 2 could equal positive 4, or x minus 2 could equal negative 4. So how do you finish that? Solve for your x, so add over your 2. So x could be 4 plus 2 is 6, or negative 4 plus 2 is negative 2. So x could be 6 or negative 2.
When do you know you can do that? Can you do it on every single problem?
Like the square root method?
Yeah.
Basically, if you have x in only one spot. So I only had one x written in the problem. So I can just square root to solve that. Here, that wouldn't work because you have an x squared, but you also have a plain x. So we can't get it by itself. So let's try a couple more of these. So again, if I'm looking at this, I only have an x in one spot. Why don't you guys solve these two by yourself? So in this one, we had our square root plus and minus, so x minus 1 equals positive or negative 2. So can we go ahead and solve these? This means x minus 1 could be 2, or x minus 1 could be negative 2. So if you add your 1, x is 3 or negative 1. This one, to get rid of a square, we square root. With that, we need plus and minus. So x equals positive or negative. What is the square root of negative 49? 7i, because of that negative. So we can have I show up here. Is that okay? So what I would like to do now is, this is the end of today's lesson. Since we're trying to get you guys ahead, since you'll be gone on Friday, I want to write down a few things, so we already have it in our notes for tomorrow, but I'll save the examples until class tomorrow. Okay? So sometimes we have quadratics that can't factor nicely and we need different options. There are two other options that we're going to look at: completing a square and the quadratic formula. So, if we have a quadratic of the form ax squared plus bx plus c equals 0, completing the square has a series of steps. We need it to be a 1x squared. So we'll divide by a if a isn't already 1. Step 2, we want the constant on the side by itself, so we will isolate the constant. Step 3, we want to make a perfect square, so we can do the square root method. So we will make a perfect square by adding b divided by 2 squared to each side. And I will explain all of this in more detail tomorrow. Step 4, we will factor. Step 5 is solve with the square root method. So this is basically a way of taking something that we can't factor and turning it into something we can. So we will look at those tomorrow. There is one other option that we can use to factor anything, and that is the quadratic formula. So we have two options. If we have this quadratic, we can do it with completing the square. Second option is quadratic formula. Which is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So, for example, if I asked you to solve this, we would always try to factor first, because that's going to be the fastest and easiest method. Is there anything that multiplies to negative 14 and adds to negative 4? No. So that means I have to solve this some other way. So we can do quadratic formula, or we can do completing the square. They both work all the time. Everybody's favorite is always quadratic formula. Completing the square does have some benefits. We need it for some things later on, so I want to practice it now instead of just saying always use the quadratic formula. I just want to start practicing it now because we do kind of need it later on. So completing the square says, first step, divide by a if a isn't 1. Do I have to worry about that? No. Second step is to isolate the constant. So that's the negative 14. So what I need to do is just take that over to the other side. And I'm just going to leave myself a little space here. Okay, my goal is to make a perfect square so that I can factor it. If you think about a perfect square, that's something like if I had x minus 1 squared, or x minus 2 squared, x minus 3 squared. These are perfect squares. And they have a pattern. When you FOIL these things out, so on our notes, what we wrote down is to make a perfect square, you take half of b, so b divided by 2, and square it. So look at these when I have them multiplied out. 8 divided by 2 is 4, squared is 16. 6 divided by 2 is 3, squared is 9. 4 divided by 2 is 2, squared is 4. So that's where the pattern comes from. That's where the b over 2 is from. So what we have to do every time is our b, which was negative 4, divided by 2, squared. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. If you add it to one side, you have to add it to the other. Because it's an equation, we have to keep it balanced. So now, what happens is this thing on the right, or sorry, on the left, will factor. What two numbers multiply to positive 4 and add to negative 4? Negative 2 and negative 2. Have we seen that negative 2 before? Yeah. That's what I got when I did negative 4 divided by 2, wasn't it? Since it's the same thing twice, we will prefer to write this as x minus 2 squared. Okay, 14 plus 4 is 18. Now here's why I want to write it with the square. How do you get rid of the square? Square root. When we add a square root, we need
Plus minus.
so get x minus 2 equals plus and minus. 18 is not a perfect square, but we can reduce it. What could we break it into? So that would be 3 3 radical 2. One step away to finish it, what do we do?
Add the two.
Add the 2 over. We'll just put it in front, so it's just 2 plus and minus 3 radical 2. So that is solving by completing the square. We will pick back up with more of those tomorrow. You don't have any on your homework tonight. Okay, so tonight's homework, there is a math Excel assignment posted. It's all ones that factor